what to do when an AI agent fails. At some point, a production AI agent is going to fail. It may recommend the wrong action. It may call the wrong tool. It may skip evidence that should have changed the decision. It may be too confident when the data is incomplete, or it may stay inside the prompt but still create operational risk because the workflow around it was not ready. That failure should not be a surprise. It should be an incident you already know how to handle. The question is not whether your agent will ever make a mistake. The question is whether you can pause it, understand what happened, limit the damage, fix the control, and prove the fix worked before you trust it again. In this video, I'll show you the response plan I would put around any AI agent before letting it operate in a real workflow. The first step is to pause or constrain the agent. Do not start by editing prompts. Do not start by guessing what went wrong. First, stop the system from repeating the failure. That might mean disabling autonomous actions, turning the agent back into assisted mode, requiring human approval for every tool call, or limiting the agent to read-only behavior. You need a kill switch before launch, not after the first incident. A good kill switch does not delete the system. It reduces risk while preserving evidence. For example, a ticket routing agent might still summarize findings, but it should stop assigning owners or changing priorities until the failure is understood. The goal is simple: prevent more damage while keeping enough of the system alive to investigate. The second step is to preserve the trace. This is why monitoring matters. If all you have is the final answer, the incident review becomes guesswork. You need the full run the input, retrieve context, tool calls, tool outputs, policy checks, approval events, final recommendation, and any human override. Preserve the exact version of the prompt, model, configuration, tools, and data sources used at the time. Do not overwrite the evidence while trying to fix the issue. In normal software, logs tell you where a system broke. For agents, traces tell you how a decision formed. That path is the difference between saying the agent was wrong and knowing whether it used stale data, skipped a required lookup, misunderstood a policy, or crossed a permission boundary. The third step is to classify the failure. Not every agent failure has the same cause. A tool selection failure means the agent picked the wrong system. A parameter failure means it called the right tool with the wrong inputs. An evidence failure means it made a decision without checking the required source. A policy failure means it ignored or misunderstood a boundary. A workflow failure means the surrounding process gave the agent too much authority. A review failure means a human approval step did not catch the issue. This classification matters because each failure needs a different fix. If the agent skipped asset context, a better closing sentence will not solve it. If the problem is excessive authority, a cleaner prompt will not solve it. You fix the control that failed, not just the words around the agent. The fourth step is to measure blast radius. Ask how many runs could be affected by this same failure mode. Which users, tickets, assets, customers, systems, or decisions touched the agent during the window? Did the agent only draft a recommendation, or did it take action? Did a human approve it? Did downstream systems trust the output? For a production agent, the dangerous question is not, was this one answer wrong? The dangerous question is, how many similar answers did we already ship? This is where failure buckets help. If one vulnerability finding was misclassified because exploit intelligence was missing, search for other findings where exploit intelligence was unavailable, stale, or skip. Treat the failure as a pattern until proven otherwise. The fifth step is to roll back or degrade safely. Rollback does not always mean removing the agent completely. Sometimes it means reverting a prompt version. Sometimes it means disabling one tool. Sometimes it means forcing human approval. Sometimes it means switching the agent from action mode to recommendation mode. The key is that rollback should be planned before launch. You should know which version was last safe, which settings changed, which tool permissions can be removed, and which outputs need review. Safe degradation is often better than total shutdown. If the agent can still summarize evidence accurately, keep that part. If it cannot, safely route tickets, disable routing. The goal is to preserve useful capability without preserving unsafe authority. The sixth step is to fix the weakest control. This is where teams often make the wrong move. They rewrite the prompt and call the incident resolved. But prompt edits are only one possible fix. You may need a required tool called check. You may need schema validation. You may need a policy gate outside the model. You may need approval thresholds. You may need better missing data behavior. You may need tighter permissions. You may need a test that prevents the same failure from coming back. For agents, the strongest fixes usually live around the model, not inside the model. The model can help reason through a task. The system has to enforce boundaries. The seventh step is to retest with failure-focused cases. Do not only rerun the happy path, build regression tests from the incident. If the agent skipped a lookup, create a test where that lookup is required. If it acted with missing evidence, create a missing data test. If it crossed an approval boundary, create a boundary test. If it used stale context, create a stale context test, then run nearby cases. A single incident usually points to a family of failures. Only after the agent passes the new failure cases should you move it back toward production, and even then, relaunch gradually. Start with shadow mode, then assisted mode, then limited automation, then full automation if the evidence supports it. Here is a cybersecurity example. Vulnerability triage agent reviews scanner findings and recommends priorities. One day, monitoring catches a problem. The agent marked the finding as low priority, but a human reviewer noticed that exploit intelligence and internet exposure should have made it high priority. The response should not be tell the agent to be more careful. First, pause autonomous priority changes. Second, preserve the trace. Third, classify the failure. Did it skip the exploit intelligence tool? Did the tool return stale data? Did it fail to check internet exposure? Did the policy allow too much discretion? Fourth, measure blast radius. Search for other findings where exploit intelligence or exposure context was missing, stale, or ignored. Fifth, roll back affected recommendations and queue them for review. Sixth, add required evidence checks before any low priority recommendation. Seventh, retest with cases where exploit intelligence changes the severity. That is an agent incident response process. Here is the checklist. Before launch, define the kill switch, log full traces. Version prompts, tools, policies, and configurations. Define failure categories. Track blast radius. Create rollback paths. Keep high-risk actions behind approval gates. Turn incidents into regression tests. Relaunch gradually. And review the response itself. The point is not to pretend the agent will never fail. The point is to make failure visible, contained, and fixable. A production AI agent is not trustworthy because it never makes mistakes. It is trustworthy because the system around it knows what to do when mistakes happen. You can pause it. You can inspect the trace. You can measure the blast radius. You can roll back unsafe behavior. You can fix the control that failed. And you can prove the fix before relaunching. That is the difference between experimenting with agents and operating them.